I want to go over how to graph the arc, cosecant, secant, and cotangent on your TIs. Now to graph the first three, sine, cosine, and tangent, is very straightforward. You're simply going to plug in the formulas. So for instance, if I wanted to graph, not that, the arc sine, I would just simply put in second sine, which will give me arc sine of x, and it graphs it. Now I might want to change the window, to better suit the domain, but that's all I might want to do. Now what about the other three? Well, now first of all, cosecant and secant work one way, cotangent works another way. So I'm going to talk about cosecant here, which is the same method you're going to use for secant. And then I'm also going to talk about cotangent, which you're going to do differently than either one of those. Now to put this into your calculator, you're going to use the same method we were using earlier to put in anything into your calculator with this. The reciprocals aren't as straightforward as they are if you're using when you were using standard trig. So I'm going to rewrite this by the definition, and this is cosecant y equals x. So then this is 1 over sine y equals x. So then this is sine y equals 1 over x, and then the arc sine of 1 over x equals y. So we're going to put in the arc cosecant as actually the arc sine of 1 over x. And then I go to graph it, and I'm going to get this graph. Now, again, you might want to change the window, look at it a little bit better, but that's the general gist of it. Even something like this really isn't any different. I'm just going to rearrange this. I'm going to first write it by the definition and get this cosecant of y equals x minus 3 pi. 1 over sine y equals x minus 3 pi. Then I'm going to go, okay, well, I'm going to reciprocal both sides, 1 over x minus 3 pi. And this is the arc sine of 1 over x minus 3 pi equals y. Now, the one thing you do want to be careful of when you're putting this into your graphing calculator is that you do use parentheses, so you do x minus 3 pi in parentheses and then end the parentheses. If you don't use the parentheses, it can often not adjust it well. It'll screw up. Now you can see here, looking at that going, I only see half of it, so I'm going to adjust my window, and I'm going to go from 0 to 20, and then I'm going to graph it again, and I've moved it over so that I can see where that's hitting. I knew I moved over 3 pi, so, kind of knowing where to look. Now, what about this last one here? This is going to require a little extra work, but again, we're simply going to rewrite it. We're going to start by moving. First, I want to isolate the arc trig function, whatever that inverse trig. So I'm going to subtract 1, and then I'm going to multiply by -1. And then I'm going to probably rewrite this as 1 minus y, because otherwise I'm going to lose that negative. And then I'm going to rewrite this as 1 minus y equals 1 over, oh, no, I was jumping ahead of myself here. I'm going to rewrite this as the cosecant of 1 minus y equals 2x. And then I'm going to take the reciprocal. So 1 over sine 1 minus y over 2x. Then I'm going to flip both sides. So this is normal, and this is 1 over 2x. Then I'm going to arc sine it. So I'm going to get 1 minus y equals the arc sine of 1 over 2x. And then I'm just going to move that 1 back. So I'm going to get -1 equals -1 plus sine of -1, 1 over 2x. Multiply, so then this is 1 minus the arc sine of 1 over 2x. Now at this point, this is finally what I'm going to put into my calculator. Okay, so I finally got to that point. I can now come over here, and actually before I go any further, I'm going to put my window back. Not that. I'll be wondering in 2 minutes why it's not showing me what I want. Again, I'm going to use lots of parentheses here, so I'm going to do the arc sine 1 over divided by 1 over 2x, and that parenthesis and that parenthesis. Sometimes I even throw an extra parenthesis in just to be extra sure. And there's my graph. And we can see, looking at this original graph, we would expect, to be flipped. We'd expect to see a vertical translation. We'd expect to see a stretch, and that seems to all be reflected here. Okay, so this is how to graph the arc cosecant. This also works for the arc secant, which is just you're going to use the arc cosine. Now, what about arc tangent? Well, that one doesn't work as nicely as we might like. Okay, I think I turned you off in between there, so let's pick this back up here. So I switched over here to the arc cotangent. So when I look at the arc cotangent, I can't put it in directly as I did. So if, and I'm just going to show you this to show you, if I put in, come on, clear. There we go. If I just put in the arc tangent of 1 over x, I'm going to get this graph. This is not what you're going to see in your book, and the reason is because of where the asymptotes are and how arc cotangent is defined. So instead what we're going to do is we're going to put it in as a translation and a reflection of the arc tangent. So I'm going to actually put this in as pi over 2 minus the arc tangent of x. And that's going to give you the graph that you see in your book. Because if you look at tangent and cotangent, the original graphs and the inverses, you'll see that they're reflections of each other. And in this case, we've moved it up just to get it off that asymptote. So when you graph this one, you do need to use this trick on the TI to make it work.